Good morning, everyone. I'm Venkatesh from eBay. So today the topic is going to be accelerating user experience with edge computing. I'm not going to be talking about how we did OpenStack with Kubernetes integration. Some of my team members spoke about this in our Boston OpenStack conference. So here we're going to take about a specific use case and see why we did it and what are the results of that. So this is all the topic is going to be today. Why we did, what we did with that, and how we did it. So just to answer these three questions is going to be the goal of it. So let's start with the why part of the question here. So for us at eBay, we are very fanatic about user experience. So it's the industry-known stuff. A faster page or a faster application makes customer really happy, which means increase in GMV, gross merchandise value, which is more money. So more than that, we kind of spent last year looking at the full stack to understand what is happening. Why, we are around the world with a few hundred million users every day, getting billions of hits a day. It's pretty one of the heavily trafficked sites in the world. And we've been trying to say, OK, how can we go to the next level of making our site really, really faster? What is that thing that's stopping us? One thing we discovered is being much, much closer to the user is very critical. So the question comes up is, hey, there is tons of public CDNs. Why can't you just use one of them? And that should solve all your problem. So we'll show some data where we could actually augment them even better for specific use cases. So as part of the analysis, we did a bunch of analysis starting all the way from the server-side backend, moving forward to the browser level, looking at IE, Chrome, Firefox, and trying to see how the rendering engines work, a bunch of those things. So we're not going to talk about many of the stuff, but very specific use case. So this is the graph. It's always interesting when I have to remove all the X and Y axis for my legal thing and still have to explain this graph. So this is a bunch of data we collected from millions of users over a 4-day period, a 5-day period time. So the blue line that you see in the bottom is the volume of traffic. As you would say, the volume goes up and comes down every day. The peaks kind of vary in the heights. That is the nature of our user experience, or the user accessing it. And then you see two lines, the red and the yellow or the orange. So the red one is where we are not using any CDN, and the orange line is where we are using a CDN. So people will say, hey, this looks like a backend server issues. You guys may be overloading on your server backend. What this test actually does is very simple. It's actually fetching a very small image from the browser. So this is something we use something called a RUM, real-time user metric data. So when a page is loaded, when we find that the user is kind of pretty much done with accessing the page, or it's not going to impact the user experience, we would download a small file, like an image, in the background without impacting the user experience. And we were measuring all of them using nav timing APIs and a bunch of those things. So to actually augment it, this is time to first byte. This is about telling how much time it took for the browser. So this is a client view, for the browser to see the data from the server. So then if you look at the actual response time, this is about downloading entire stuff, the CDN does help. Like if you see the gap between the orange line and the red line, yes, CDN do help. But still, there are little kind of like spikes during the peak time. We want to make sure that we provide a very, very consistent experience to our user. We don't want it to be faster at one part of the time and be slow at other part of the time. So what do we have to do? So the answer to that is, as I mentioned earlier, to get closer to the user. So did I go? OK. So here's one of the example, which we kind of found in the field. This is very interesting. I'm not saying all of them are like this. This kind of shows about the variability in the network path. So this is one of the capture we did from one of the synthetic locations to understand what's happening. It was very simple. We're trying to do a kind of like understand a user experience from Telstra in Australia, Perth, to one of our services. So this was not going through a CDN, but we're trying to go just across internet. What you would see fun is like it starts from Perth, goes to Adelaide, goes to Melbourne, goes to Sydney, and then goes to China, goes to Germany. People could always say, hey, this is a routing problem, you guys could solve it. But this is not a consistent problem. The issues comes and goes away, right? We were lucky enough to capture one of this. We were doing a lot of other captures, and we did find one of them. So some of these are the kind of the erratic spurs that's kind of causing those little spikes for us. So how do we solve this? The question is, we want to get much, much closer to the user. When we get much closer to the user, then we have to be, it's kind of going to be very expensive, both in terms of computing and also in terms of real estate. So we have to be much, much efficient in terms of running our applications there. OK, so what did we do? So what we were trying to do was very simple. So this is our page. And as you would see, there is a first HTML call that we make back to the origin. The call actually goes to the origin for a few reasons, like experimentation, tracking, a bunch of other things that happens with it. So in that, we are trying to see if we could accelerate that part of the flow, then the rest of them could be actually accelerated along with it. Every millisecond we save on that is going to actually contribute to the rest of it for us. So as you would see, this is from one of the capture. We found that the time to first byte for the first one of them is 220 milliseconds, which is like really bad for us. We are trying to make it more optimized. OK, so we did a bunch of things. I'm not going to talk about all of them, but only the one that's in the yellow color. So we did a lot of SSL optimization. We did TCP optimization. And then the last one is an application level, which I don't think we have time today to go more into it. But that actually gave us a leapfrog approach, maybe for another day. So what we're going to talk today is more about reduced variability in the network path via internet. So we've been looking at it. We have users across both desktop and mobile. So for the first three of them, it's almost the same. Whatever we do for one applies for most part for the rest. But the caching is very different, which is a different beast to handle altogether. When I meant caching here, I'm not meaning caching an image or a JPEG or a CSS, any of them. It is about caching your dynamic data at a very rapid pace. So OK, how did we do it? OK, so this is a very simplified view of it. So today, or earlier, the way it used to work is the user would go to a CDN proxy, and then CDN proxy would come back to our origin just over the internet. The thickness of the line does say the latency and the bandwidth of what's available. So as you see, before the bandwidth between the user and CDN proxy was high, but CDN proxy to us, because of the latency and the path it took, we found that a lot of time it was varying. So we want to do something very simple. We want to drop something closer to the CDN proxy or closer to the user for different reasons. And as you would see, the black lines are the lines over the internet, and the blue line is over our backbone. And you would see that we actually reduce a variability of path. So we are reducing that, OK, the path that can vary is being shrunk a lot. So what this provides is a huge incentive or huge benefit for our user experience to our end users. So let's see what happened. So this is the result. So the green one is an hybrid, which is using both of them. As you would see, there is literally no peaks anymore. We kind of removed the peaks out of it, which means we are providing consistent user behavior to our customers, which is very, very critical for us. Like, irrespective of the platform, irrespective of the place in the world our customers are, they should have best possible experience. So as this is the time to first byte, as you would see, it has reduced it. And this is pretty good for us. So how did the entire response work? So we actually did even better with the response. Downloading the entire content also kind of got accelerated by doing this method. So if you see, the green line is the hybrid thing what we did. And the yellow one is a CDN, and the red one is going directly back. As you would see, we not only made it better at TTFP, but also downloading the entire response time. This entire response is not a page load time. It's for downloading the entire HTML so that the rest of the content can start downloading. So this actually has helped us to move much, much faster. OK, our lessons learned. Measurement is key. There is a lot of synthetic measurements you could do one of, but we find RUM is the best. And the measurement, we built a huge framework where we'll be able to kind of tune it up in terms of make real-time calls to it, be able to pull a lot more data out of it. So do invest in RUM, which is very, very important for you guys when you go into the edge, because we are going to the edge for the reason of making our user experience better. So we should really know how our users feel it, not how a machine sitting in a data center experiences it. There is a big difference between them. So RUM is the best. Next one, designing software stack for edge. This is very, very critical for us. We are a pretty big OpenStack shop. We run one of the big private cloud as well. So a lot of time the discussion comes between ourselves and the infrastructure teams about cattle versus pets. So when I have limited computing power, I can't have this argument of cattle versus pets when I go into my edge. Edges are going to be much, much smaller footprint. So it's somewhere in between, or it's mostly pets. What it means is every CPU cycle matters for us. We cannot afford to waste any CPU cycles or memory out of that. So it has to be fully optimized. So we don't run VMs. We run on containers. So in a Boston earlier OpenStack conference, the team introduced our contribution between OpenStack and Kubernetes called as test a project. So, and then security and operations are part of the design. When you go into the edge, you're going to be susceptible to DDoS, so which means you need to be able to solve them. So security and operations are not after the fact. You cannot take it for granted, and you actually have to rethink how you do it. Operations at edge is very different. So there's a macro and a micro picture. This is a very interesting thing for us to talk about. The reason is, when early on we started discussing about it, people are thinking about how much computing power can I actually stuff in my edge without having to do other things. The question is like, okay, can I use, how about for security? How about for other aspects of third-party appliances or containers I could do? The question is, some of the problems you could solve from a macro picture rather than from a micro picture. During DOS attack, you could figure out how you want to route the traffic even before it hits you. So don't always try to solve the problem at a micro level. Also, there are problems you could solve at a macro level, looking at the entire architecture. And the last one is failure modes. The failure modes are way, way different. When we're building data center, it's much different failure modes comparing to edge. You'll be exposed to a lot more gray failures. The gray failures are very hard to detect and troubleshoot, and that's where measurement comes in place, because you might find for the same user in the same network, one of your pop is doing awesome, but the other pop is not doing that great. So Ram is your best friend who's going to come and rescue us. So these are the lessons that what we learned in the process. And this is a journey what we started earlier this year. We are taking baby steps. We are in a much early or much primitive stage of it. We'll be sharing more and more as we progress. And to summarize it, Edge is actually helping us to make our user experience better, which we value the most, because our users should have the best possible experience. And when we start doing it at the edge, the dynamics of what we used to do is changing a lot. And OpenStack and Kubernetes are things that what we're using for most part. And that's pretty much from me. Thank you.